Hello everyone, this is Khanfar here. Today I'll demonstrate to you our new software is calling Khanfar CFAR Mask Analyzer. Actually, what makes this software is unique is the combination of two powerful technologies, and we implement the constant false alarm rate. It's calling CFAR algorithm, and we implement our advanced frequency masking technology. And the CFAR algorithm, it's a dynamic threshold technique originally developed for radar systems. Unlike a classical fixed threshold, which fail when noise level change, so CFAR continuously adapt to the surrounding noise floor by calculating a separate threshold for each frequency band. This result in significantly better detection performance in varying RF environment, fewer false alarms, and the ability to detect weaker signals that would be missed by a static threshold method. And for second, advanced frequency masking technology, unlike simple bandpass filters, our mask can be precisely trailed with adjustable ranges and inverted for execution or inclusion, and even shaped as a triangle or square to better match the spectral signature of real-world signals. So that this means you can focus exclusively on frequencies of interest while ignore non-interference. Now let me walk you through these features and show you how they work. Let's go into our website for understanding the concepts of CFAR and masking technology. And you can see from here the signals, as you can see in the blue lines, and here the CFAR threshold in the yellow lines, as we can see from here. And you see here that threshold here, it's a dynamic based on the signal spikes in the spectrum. As you can see, when I increase the CFAR threshold, look what's happening here. And when you change the guard cells, and you see when we change the reference cell, you can see how these touch the signal. And let's going to fix the threshold. As you can see here, the fixed threshold, the issue when you going to the noisy environment, so the fixed threshold give you a false alarm. So in case in traditional threshold detection method, fixed threshold value, when we put and any signal peak above this threshold is considered detection. And however, this approach fails in environment with varying noise level, that leading to too many false alarm in high noise areas and misdetection in low noise area actually. And the CFAR solve this by dynamically adapting the threshold based on local noise environment, as we can see from here from the graph, around each potential signal and for each point in the spectrum. So this here the reference cell around the point are sampled, excluding guard cells, and the local noise level is calculated from these reference cells. And the threshold is set as a multiple of this noise level, and if the signal exceed this adaptive threshold, it's become to as a detection. As you can see from here from our website, we put types of CFAR implementation, and we put many things here so you understand everything. And here let's going to try to toggle the mask to let you see what mask doing. This mask, it's ignore in the spectrum a specific area, specific frequency, as we can see from here. And it's going up for the masking. As we can see from here, the mask functionality allow you to define signal-free areas in the spectrum where you expect no signals or want to ignore existing signals. The software automatically adapt this mask, preventing false detection in non-signal area while maintaining high sensitive in areas of interest. As we can see from here, everything, we have two types of masking. We have a rectangle standard mask, and we have a triangle So our software it's have dual masking actually technology, and you can see here all information and you see here the triangle only detection visualization. So you can see from here many important things to understand the software. So it's recommended you understand the software before you start operating the software. Now let's going back to our software. As we can see from here, you see here real-time FFT-based spectrum visualization, and you see we have an advanced CFAR algorithm for integration signal detection and comprehensive frequency masking system. And we have a visual and audio alert for signal detection. And we have a persistent configuration and settings management here in our software. So first of all, when you're running the software, you need to put your RTL-SDR dongle before running the software. And from here in the left, you need to click reinitialize SDR. And then after that, you start. You see here the sample rate. You see here the ppm correction, the frequency. As you can see here, our frequency now in 101 megahertz. You can see here the CFAR threshold. It's dynamically going with a spectrum, and here we have a guard cell, and we have compute cells, and we have a base. So let's try to increase the base so you understand what this base do. As you can see here, when I make the base down, as you can see from here, the orange, all these become as a detected signal. Now let's going to play with this up, as you can see from here. So, and we have here a guard cell. From here, you see a guard cell. The guard cell, this determine how many cells around the potential signal are ignored when calculating the noisy floor. And for narrow signal, use lower value like around 160, or you can play and do and understand what are these. And we have here a compute cell, and this determine how many cells you are used to calculate the noise floor. And higher value around like 160 to 200 give you more stable detection. You can play on that. Now we will test this with a signal for remote control. And first of all, let's let you know all these parameters. And for the CFAR base, as I say, this essentially you sensitively control, and lower value like 3.5 increases sensitivity but may cause false alarm, as you can see, and you can adjust these parameters. So it's going to put the frequency for remote control. Now I put for 34.5, and let's decrease the gain to like 10, and let's do apply parameter. We need to do apply parameter. Okay, now let's start to click on the remote control. As you can see here, the CFAR threshold detect the signal here. This decrease the guard cell. Look how the teeth now going wide and going narrow when I am pushing the remote control. And you can change the compute cell. As you can see from here, you can increase the bias, as you can see from here. Now let's try to add the mask. So to adding the mask, you need to add center frequency, and then enable trigger mask. As you can see here, the mask going at the center frequency. From here, we can move the mask. So let's move it here. Now let's try to push. As you can see, signal detected because we activate the mask here. And you can invert the mask, as you can see, using exclude mode. Now the mask become to the red. Now let's try to push here. No, nothing detected. So when I try to transmit anywhere in the spectrum, I will get detected signal. Let's try to send in a frequency TX 4 3 like 4.8. As you can see, now we have a signal detected because we put a mask here in this area. Now the signal detected is based on the CFAR. And you can add more masks as you like. Just add to the center and you can move it to the right, and you can decrease or increase the mask size, as you can see from here. And you can, from here, you can use a triangle only detection. Let me tell you what this triangle only detection do. Now, as you can see from here, the triangle become in different color. So it's going to make it exclude mode in the green line, so it's easy to see. Now let me try to increase. Here you can see from here you have a triangle base. When we increase or decrease it, as we can see from here, it's decrease or increase the base. As you can see, let's put it like in 2. Here the notch width, if we can increase the notch or decrease, and we can make like this. Now from here, let's try to send. As you can see here the mask, but it's not touch the triangle. Now nothing detected because we activate the triangle only detection. So actually any spikes become here in this inside the triangle, it will be detected, and you can see the alarm, and it will you will have a log to your PC. So now let's try to move the mask a little bit to the left. May need a little bit to the right. Let's move it like here. As you can see, now the signal detected based on the triangle mask we add. So this mask have a 2-layer, one for this box and one for this. You can activate or deactivate the layer of the triangle if you need. If you no need, as you can see from here, you can like decrease the mask, and you can invert, as I say to you. And now let's going to, and we have here a visual alert and visual alert with sound, so you can choose which one you want to use. And here you can save the setting for next launch of the software, and you can see the log from here. We can go into the signal detection. As you can see here, the last one, it's mode normal, center frequency, and signal strength, and detection, and location inside mask. And here you see location inside the triangle mask, and we have location outside mask because we make a exclude mode, and we have a mode normal, and you can see every detected signal here in the log file, as you can see from here. And when a signal is detected within your mask area or outside them if inverted. The software provides immediate feedback with visual highlights on the spectrum display and alert indicator, as you can see on the interface. And it's a configurable audio alert through your computer speakers if you activate it. And as you can see, like it's automatic logging to a detection file with time stamps. And you can adjust the detection parameters to minimum SNR, signal to noise ratio that's required for alert, and threshold for detection sensitivity, and alert cooldown to prevent repeated notification for same signal. So finally, the CFAR mask analyzer transform an inexpensive SDR device into a professional spectrum analyzer system. It's combined advanced signal processing algorithm with inductive control to give you a powerful RF monitoring capabilities. Okay, YouTube, this is Khanfar here. Thank you for watching and stay tuned for next demonstration video, and ciao ciao.